Okay, let's do an application with vectors. And quite often we do this in navigation. I want to give you a little bit of background here. First of all, in navigation, when we talk about, let's just talk about an airplane. We have an airplane that's has a heading of due east. Heading is basically going to be its direction. And direction, let's make sure we know our directions. We have north, south, east, and west. What is this? Never eat soggy waffles. There we go. North, east, south, and west. So we have the heading is basically our direction that we will be using. And when we talk about the magnitude in terms of navigation, what we're talking about is speed. And there's two different speeds that we'll be dealing with. We talk about airspeed and we talk about ground speed. Airspeed is the speed of the airplane relative to the air. Ground speed is the plane's speed relative to the ground. So if there are no wind effects, so the wind's not blowing and there's no effect from wind, ground speed and airspeed would be equal. They would be the same. That doesn't happen very often. So if we have a vector v, vector v, we're going to say is our velocity vector. For our airplane. And vector v has a magnitude, which will be its airspeed. Okay, so its magnitude is its airspeed. And its heading will be its direction. So its direction will be given by its heading. There's that vocabulary word there. And then let's say that there's also wind happening. So this is all about our airplane here. Let's talk about the wind that's taking place. When we're talking navigation, we're going to deal with the wind. And so wind is same thing, our magnitude. And again, this is our, we'll have W represent our wind. Where W has its magnitude and its direction as well. So when we put the velocity of our airplane, when we take our airplane, our vector, our magnitude and direction, and add it to the wind that's happening, what we get is called the course. It's the direction in which the airplane is moving with respect to the ground. So as the wind takes the airplane's going this way, the wind starts to push the airplane and act on the airplane. It starts a drift. This resultant vector then is called its course. Its direction is our drift angle. The direction of the resultant vector is the drift angle. Now, another thing you need to know when we're dealing with navigation is that we measure everything from north. So this is going to change our angles and how we think about things just a little bit, but everything is measured from north in a clockwise direction. So let's take a look at an example. The heading and the airspeed of an airplane are 60 degrees and 250 miles per hour. Okay, let's draw that. So here's north. Our heading is 60 degrees. So we measure from north and we're going to come down 60 degrees to a magnitude of 250. Okay? So this is a 60-degree angle right here. That's our heading. Now we have a wind that is 40 miles per hour from 150 degrees. Okay, so our wind 40 miles per hour from 150. It has a heading of 150 degrees. So we're going to start from north and we're going to measure 150. So there's 90. From north, this would be 180. So here's our 150 down here. So it's coming from this direction. That means that it's also working this way. So I could have it, this wind is coming from the 150 degrees at 40 miles per hour. Okay, so we have one vector here, we have one vector here. We can use our rule of parallelograms to find our resultant vector. So our resultant vector is right there. We can draw the picture and see where it should be. But let's go ahead and calculate this. First of all, to find our magnitude. Well, now here's the other thing. Let's just see what kind of angle we've created here. We've got some math to kind of figure out. Our angle that we've created between this vector and this vector, if this was 60 and this was 150, we have a 90-degree angle in there. 150 minus 60 gives us a 90-degree angle. So we have perpendicular vectors, and when we worked with perpendicular vectors before, it became real easy because we can just say a squared plus b squared equals c squared. So my magnitude of this resultant vector, I'm going to call it d again, is just the square root of 250 squared plus 40 squared. On my calculator, I plug that in, and my magnitude is 253.2. Okay, so when I have my airplane going at 250 miles per hour with a wind speed of 40 miles per hour going in this direction, my ground speed is actually 253.2 miles per hour. Now the drift angle, the effect of the wind is going to have an effect on this airplane. So the drift angle, what I'm looking for is this angle right here. And so my theta is this part here. I want to find that drift angle. And again, I'm going to go ahead and use tangent, which is an opposite over an adjacent. So the tangent of theta is my opposite over adjacent. Do an inverse tangent on that in order to find theta. Inverse tangent of 40 over 250 turns out to be 9.1 degrees. So my drift angle is 9.1 degrees. What that means is if I want to set my course for the airplane, right now we said that it had a direction of 60 degrees, and the wind is going to push it 9.1 degrees. So what that means is that to set my course is actually the 60 minus the 9.1. My course, where I end up, is 50.9 degrees. Again, that's measuring from north, clockwise. All of our measurements. Okay, navigation. Little bit different because we're measuring from a different direction, but we'll give it a try.